Okay, we're working our way through polymorphism, and we're going to talk about parameter coercion right now. And there's really two main concepts that are going to pop out of this section, and one of them kind of deals with types, and the other kind of deals with definitions. But we'll kind of walk through it. And we're going to start with coercion. Um, so, what coercion means is that we're willing to convert the type um, even if the programmer leaves it out, as long as it makes sense, right? So, for example, if I do this top example here, these are both in Java, but here in Java, I declare x to be a double, right? So x is of type double. I take the number 2, and this right here is a cast. I mean, if you remember that from Java or C++, this is casting. It basically says take this number, which in its kind of native form coming here, there's no decimal point, is an integer, right? And I'm going to make it into a double and then assign it. That's explicit type conversion, okay? Where I say convert the type, change the type. We can do that in ML, right? A little bit. Well, in this example, I don't do that. I just say double x and x gets 2. And you're like, wait. On the one hand, I defined x to be a double, 2 is an integer. They're not the same type. But basically what Java's doing there is saying, that's okay, 2 is an integer. An integer is a subset of the set of values that exist in doubles, right? And if double has got 2 integers and I've only got 1, I'll just pad the other one, with either ones or zeros, depending on whether it's a positive or a negative number. I'm just going to pad it. I don't care. And that's coercion, where it's an implicit type conversion as opposed to an explicit type conversion, okay? So, different support in different languages, okay? And you knew I was going to go there, right? Because that's always the case. And it depends on the context, right? What about during assignments? What about binary operators when you have 2 operands? What about unary operators when you have only 1? What about parameters as they're coming into function calls, right? And so this part here becomes kind of important, right? Which is that when a language supports coercion of the parameters on a function call, or the operands when an operator is applied, which is really in effect a function call, that resulting function is referred to as a polymorphic function, okay? Because that operator will operate on things of different types without having to say it explicitly, okay? And here's an example from Java. So in this example, I have got this function f, and it wants a double, right? It's going to take a value of x internally, and it's going to be of type double. Now, it turns out that any of these examples in Java, it's willing to take this one, which is an integer, cast it into a byte, all right? I'm taking that integer and I'm truncating, it's typically integers are 16 bits, not always. But if I've got a 16-bit integer, this is literally saying just ignore the high order 8 bits. Just give me the low order 8 bits. So you better dang well be sure that you've got a number that's going to fit in that, right? But I cast it into a byte, and then I pass that byte in. Java goes, that's all right. I can turn a byte into a double. I can turn a short into a double. I can turn the character A into a double, right? I got the integer 3. I've got a long. I've got a float. I can turn them all into doubles, it turns out, and Java's willing to do it. And that's, it's really, that's kind of cool, right? But there's some of them that make you kind of go, whoa, what about that? Really? Yeah, and this is kind of a core idea, because one of the things we're trying to understand in this class is kind of how different languages do what they do, and some of the decisions that go into it, right? What you've learned is not the only way to do it. It's a bigger world out there. And so defining these coercions takes a lot of effort. And in fact, I'm just going to jump over. There's an example, just a small chunk from Java. I'm not going to go into this, right? But I'm not going to read the whole thing, but just as an example, right? If the operand's a compile time type, notice again, we talked about compile time, link time, right? All those things. This is in the Java spec. Compile time is a relevant issue. If it's byte or short or character or an integer, then it's got all these terms and blah blah blah. And then I think it goes like 10,000 words in the Java spec to articulate how to do coercion, which is that implicit type conversion, right? So some of the older languages like Algol 68, which I never programmed in, PL1 I actually programmed in, believe it or not, when I was 17. And believe it or not, when I was 17, I didn't know that it had extensive powers of coercion. Okay, I didn't know. All I knew was that I sucked at programming in PL1, and it was on Hollerith punch cards, and every punch card was a separate line of code. You think you got it bad right now? I'll tell you what, that was no fun. And then there's languages like ML, no coercion, no implicit conversion ever. And then most of them, like Java, are kind of in the middle, right? And then like C++, where I can like kind of talked about, define certain things, but again, most modern languages are kind of in the middle. I'm gonna skip past that one. And then really kind of I think this is the last part of this couple slides, and then we're out of this part. But some of the tricky interactions, okay, when you deal with overloading and coercion. This next part's going to sound a little tricky, right? These next two bullets. Overloading uses type to choose the definition. Coercion uses the definition to choose a type conversion. Okay, so let's look at this. So what that means is, if you remember overloading, I've got like the plus operator, right? And I'm gonna have a different function if I'm adding doubles, and I've got a different function if I'm adding ints, things like that, right? So I use the types of my parameters to choose which definition I'm going to use, all right? With coercion, I use the definition to tell me what conversion I'm going to do, what kind of type conversion I'm going to do, okay? In other words, if I got a function that expects a double, then I'm going to use that definition of that function to tell me to turn that int into a double, okay? And they're different. It's kind of looking at it from different angles. Here's an example. So imagine that I've got a language like C++ that the language is willing to turn a character into an integer or to turn a character into a double. Here's where the subtlety comes into play. I call square and I pass it a character, right? And let's just say that square, okay, so I've got two functions for square. I've got square that takes an integer and returns an integer. I got square that takes a double and returns a double. And I'm passing it a single byte as a character, passing it a character, right, into square. Which one do I call? And frankly, I don't even know which one it is in C, right? But what is it? Is it the one that's closest to it? Would you use the int guy because he's closest to it? Or would you use the double because he's just the biggest distance and will just be more safe? What do you do? Well, I assure you that that's in the C++ spec. And I also assure you I don't know it off the top of my head. Here's another example. That suppose also like C++, we got a language willing to turn a character into an int, right? And I got these two functions f, right? And this one here, I've got f is going to be an integer and a character. Those are the two parameters. This function of f, and this is just overloading, right? I now have an f that you can pass in an integer and a character, and I've got an f that you can pass in a character and a character. Okay, sorry, a character and an int, right? Int and a character and an int. But they're both f, and depending upon the type, I'll decide which function I'm going to call. But what about this one? I mean, seriously, I've got f with two characters. So I match one of the parameters, but I don't match the other one. And in both cases, I don't know what the answer is, because the answer itself doesn't matter. They had to make an arbitrary decision on that in terms of how they were going to handle that kind of coercion. Okay, and that's the end of our discussion of coercion and that implicit type conversion. Okay, what we're going to come back to on the next one is parametric polymorphism, and we're about the midway point, maybe a little past the midpoint for this overall chapter 8.